Now, fold classification. This is the beginning of what you're going to do with that drawing that you did. There are 4 things that we want to identify. We want to look at the fold shape in 3 dimensions. Is it cylindrical or non-cylindrical? We want to look at fold facing. Is it upward facing or downward facing? Where is the young rock? Where is the old rock? We want to look at fold orientation. Is it an antiform or a synform? What else can we see about it? And we want to look at fold shape, the profile in the plane, the tightness, the tilt, etc. So, fold shape in 3 dimensions. We got a cylindrical fold. This is everything hanging on that towel rod nicely. It's draped over a cylinder. Straight hinge lines, nice and basic fold. Sometimes you can find a cylindrical fold if you look smaller scale, 100 feet, quarter mile, something like that. If you try extending out for a mile or 50 miles, it's going to be really hard to find something that maintains a cylindrical fold shape. So at a smaller scale, it's more common to find a cylindrical fold. Non-cylindrical could be like B, where we've seen this before, where it kind of been folded once in another direction, or it could be like C, where it's been folded over and over and over again and looks like, a pile of soggy noodles pulled out of a pot. Fold facing. Younging upward, upward facing is like A and B, where this young rock is on top. Again, young rock on top. So we have this antiform is an anticline. This synform is a syncline. But examples C and D, we have youngest on the bottom. This is an antiform. C is not an anticline. Even though visually it could look the same. You could have another sandstone layer that was older than this shale. The little dots generally mean sandstone. The little dashes, all parallel to each other, generally mean shale. And so this is alternating sandstone and shale. And they could be in the same exact pattern of, sandstone on top, then shale, sandstone, shale, sandstone. But it's about the ages, not about rock type. Okay, then over here in example D, we have oldest on top in the core and youngest on the bottom. So it is a synform, but it is not a syncline. Now, fold classification, the fold orientation. You can see here, this fold is plunging. It is not horizontal. So the hinge line is not horizontal. It is plunging down into the ground. The plunge of the hinge line can be at any angle from 0 to 90 degrees. 90 being straight down into the ground, 0 being the hinge line is horizontal. And these are the 5 categories that we identify. We don't necessarily need the precise angle. If it's anywhere from 0 to 10, we call it a horizontal fold because it's pretty darn close to horizontal even at 10 degrees. A shallow plunge is anything from 10 degrees to 30 degrees. An intermediate plunge, 30 to 60. A steep plunge, 60 to 80, and then anything from 80 to 90 we call vertical, even though technically, sure, 80 degrees isn't quite vertical, but that's pretty darn close to vertical, especially for a fold in solid rock. It's been tilted a lot. So, as an example, in this picture here, it looks to be somewhere in the realm of 25 to 35 degrees. I don't have a protractor on my screen, but probably about 30 degrees. So if once you do measure it, you find, hey, you know what? It's actually like 28.7 degrees. It's a shallow fold, or a shallow plunge. So you would say shallowly plunging fold, plunging to the northeast, if it was plunging to the northeast. The plunge direction is whichever way it's going down into the ground. So in this case, assuming north is up on the page, this one would be plunging to the northeast. If, on the other hand, you say, you know what, it's 30.2 degrees, it's an intermediate fold, or intermediate plunge. So you would say my fold is plunging, or has an intermediate plunge to the northeast. Now, the axial surface can be at an angle as well. But let's look at another plunge first. I don't know if you've noticed, but for me, the text on this box I'm showing you doesn't look straight. So what's the plunge of the table? Is it shallow? Is it horizontal? Well, visually we can see it is not horizontal. It is definitely dipping. But geologically speaking, the text in this box is horizontal. So that's just kind of to help put it in perspective. It's clearly not straight, but it gets classified as horizontal. Now moving on to the dip of the axial surface. We have three categories: recumbent, inclined, and upright. You notice they're not evenly spaced. Recumbent only covers 10 degrees, upright covers 20, and inclined covers 60. So what do they look like? Recumbent means that it's almost completely to the side. Think of like a recumbent bicycle. It's sitting back, tilted. So a recumbent fold is the most tilted possible. Basically, that axial surface is horizontal or within 10 degrees of horizontal. Inclined is where the axial surface, basically going right through the middle of that angle, is tilted anywhere from 10 to 70 degrees. And then upright is like this. Now, I've drawn it as an upright antiform. The angle could be at the bottom, and it could be an upright synform. But the point is that the axial surface, going right through the middle here, is up and down. The dip of that axial surface is between 70 and 90 degrees. You can see here some drawings from the textbook, 3D drawings that show axial surfaces and the limbs and the fold axes, or the hinge, and some cutaways to see what would I see in a road cut, what would I see, cross section, and the surface exposure. What would I see from that eroded ground surface? And, for example, a vertical fold or a vertical axial surface. So this is this vertical for the plunge. On the ground we see a big V because the two limbs are exposed from erosion and the hinge is off to the side and the plunge is vertical. On the other hand, if we have a horizontal, so horizontal right here, the plunge, we'll just see a stripe, or if it were eroded further down, sets of stripes. On the other hand, plunging somewhere in between that vertical and horizontal, it's plunging at some angle, we're going to again see a V shape on the surface. We're also still going to see some V or arch shape from the side. It's intermediate of those two. We can have, and this is upright where the peak is vertical, the axial plane is vertical. See, all three of those first ones, the axial plane is up and down. Now we're getting into the axial plane is tilting. It's inclined. So we have inclined in the second row, where we had upright in the first section. So we have an inclined that's plunging, an inclined that's horizontal, and reclined is kind of just an inclined plunging. It's another term for it. It's at slightly different angles, but it's the same thing. It's inclined and plunging. Recumbent, down in the bottom right, is this top one, and this one happens to be a recumbent horizontal. It's not plunging, it's just recumbent. Now we've got another plunging table of text here. And we want to talk about how tight, how small or large is that interlimb angle. Isoclinal is very close together. Almost no angle between them. So they're, close to parallel almost, the limbs are. So anywhere from 0 to 10 degrees. Very, very narrow, very tight. The limbs are close together. Tight is where the limbs are between 10 and 60 degrees apart from each other. Open is between 60 and 120 degrees between the limbs. And then gentle is between 120 and 180. 180 would be just a straight line. So there's no folding. So anywhere, any amount of folding, so 179.99 down to 120 degrees is a gentle fold.